Welcome to this Nallatech webcast, presented in partnership with Altera, the leader in innovative customer logic solutions. My name is Craig Petrie. I am responsible for business development at Nallatech, and I'm based at their European headquarters in the UK. Today I want to provide you with an introduction to Nallatech and explain how we're working with Altera to provide FPGA-based solutions to customers in the finance market. Many of the people listening to this webcast will know about Altera, or at the very least have heard of them. The first thing to note about Nallatech is that we have been operating in the FPGA market for over 20 years now and specialise in FPGA accelerator hardware, IP and design services. We were established in 1993 and were one of the first companies to sell FPGA hardware as commercial off-the-shelf products along with IP and tools. The Nallatech Group has an in-house manufacturing, test and packaging facility based in California, and all of Nallatech's products, including the Altera Stratix V line of products, are manufactured there. This in-house capability, coupled to Nallatech's US and UK based engineering centres, uniquely position Nallatech and set us apart from the competition. During the early years at Nallatech, we sold development and deployment products to government, defence and telecommunications companies who were at the leading edge of technology adoption. We recognised the potential of FPGAs to address demanding real-time network processing and co-processing applications and tailored our product strategy accordingly to focus on these application areas. Over the course of the last few years, we have engaged with customers in the finance market who have been using FPGA-enabled network processing cards for high-frequency trading, where the focus is ultra-low latency performance. These customers have typically been electronic engineers who understand digital circuits, using low-level hardware description programming languages, and in some cases MATLAB DSP tools. The recent introduction of OpenCL by Altera for FPGAs has piqued the interests of many finance customers, predominantly software engineers and programmers who see the performance potential and cost savings associated with energy efficient FPGAs. Their main interest is in using FPGAs as co-processors in a similar way that GPUs are used today for compute intensive applications such as order book building, risk analysis and Monte Carlo simulations. The inclusion of FPGAs in heterogeneous compute platforms requires the successful integration and deployment of PCI Express FPGA accelerator cards within traditional data center environments. Nallatech is the only FPGA card vendor with product formally qualified for both HP and IBM platforms. Is very well positioned to meet the requirements of this class of customer. Nallatech has two Altera-based market-leading FPGA accelerator cards capable of addressing the latency critical and co-processing requirements of customers in the finance market. The first product is called the 385. The 385 started shipping February 2012 and has proven extremely popular, notching up a number of design wins. It is a low-profile PCI Express card, the same size as a typical NIC card in fact, meaning that it is half the height and half the length of the full-size PCI Express specification. This allows the card to be populated in almost any server or blade in the market. The architecture is simple yet powerful. At the heart of the card is an Altera Stratix V FPGA. The standard product option includes an A7 or a D5 device, giving customers a choice of logic and embedded blockgram and multiplier ratios. The host interface supports PCI Express Gen 3, with 8 lanes delivering up to 10 GB per second of sustained bandwidth, split evenly between read and write directions. Note that the total bandwidth and latency are dependent on a number of factors, including host operating system, chipset and use case, so it is recommended that customers benchmark the performance of the card for their particular hardware configuration and application setup. Directly coupled to the FPGA are two independent banks of DDR3 SDRAM. The standard product ships with two 4 GB banks populated, However, it is possible to support up to two 8GB banks for customers with demanding memory bandwidth and capacity requirements. In combination, the PCI Express link, the Stratix V FPGA, and the DDR3 memory provide customers with an exceptionally capable compute engine for co-processing applications, where the 385 is used as an offload engine to the x86 processor. For applications that involve interfacing to networks or even storage arrays, the two SFP Plus network ports transform this card from a classic coprocessor function to a real-time, low-latency I/O engine capable of performing tasks that are either impossible in software or previously only dealt with by expensive ASICs. The two SFP Plus connectors are wired directly into the Stratix V FPGA, so there is no PHY or transceiver chip within the data paths. This means that the card is capable of supporting a wide range of network protocols, including 1 gigabit Ethernet, 10 gigabit Ethernet, and SONET SDH. Other protocols are also capable of being supported, such as Fibre Channel and InfiniBand. This means that the 385 card can be deployed as a port interfacing to local networks or the wider internet, or as a direct interface to storage arrays and data center routers. The power consumption of the card is application dependent. However, 25 watts is probably the average. Power is derived solely through the 3.3 volt and 12 volt connections of the PCI Express slot connector, so there's no need for GPU style auxiliary power cables. The standard product ships with a single width active cooling solution. Passive cooling solutions using only heat sinks are available for customers who demand highest reliability and best MTBF. However, note that system level qualification is required to ensure correct operation of a passive cooling solution. Customers can purchase a 385 card directly from Nallatech or via one of Nallatech's international sales partners. The 395 is a more recent product, launched March 2013. The 395 is effectively the 385's big brother. It's targeted at the same class of latency critical and co-processing applications as the 385. However, it has twice as many network ports, approximately double the logic density, and up to 3 times the memory bandwidth. The 395 complements the 385 by delivering the ultimate performance end of the Nallatech product range. This card is the same height and length as a typical GPU card from NVIDIA or AMD ATI. However, unlike most GPUs, it is possible to use a 385 in a single width PCI Express slot. The architecture is simple, like the 385, but scaled up for highest possible performance. The standard product option includes an Altera Stratix V AB or D8 FPGA from the 45mm package size. The host interface supports PCI Express Gen 3 with 8 lanes, delivering up to 10 gigabytes per second of sustained bandwidth, split evenly between read and write directions, just like the 385. Again, the total bandwidth and latency are dependent on host operating system, chipset, and use case, so it is recommended that customers benchmark the performance of the card for their particular hardware setup and application. Directly coupled to the FPGA are 4 independent banks of DDR3 SDRAM, capable of supporting up to 8 gigabytes per bank, providing a massive 32 gigabytes total memory for customers who need maximum memory bandwidth and capacity within the constraints of a PCI Express card. The 4 SFP Plus connectors on the 395 are set up in the same fashion as the 2 ports of the 385 card. So the same wide range of network protocols, including 1 gigabit Ethernet, 10 gigabit Ethernet, and SONET SDH are supported, in addition to Fibre Channel and InfiniBand. The 395 has a bonus feature not supported on the 385. There are 2 independent banks of QDR2 plus SRAM memory that can be used for quick, shallow, random access. Some customers find this type of memory useful when performing packet filtering and inspection routines. The power consumption of the 395 is also application dependent. Customers exercising the full card can probably expect to consume about 75 watts of power. As a reminder, high-end graphics cards can consume several hundred watts, so the 395 is still very energy efficient by comparison. The power is derived through the 3.3 volt and 12 volt connections of the PCI Express slot. However, a 6-pin GPU style auxiliary power connector is available for platforms that cannot supply enough power via the PCI Express slot. The standard product ships with the double width active cooling solution. Double width and single width passive cooling solutions are available following system level qualification. Customers can purchase a 395 card directly from Nallatech or via one of Nallatech's international sales partners. In order to reduce the risk associated with the evaluation and deployment of FPGA accelerator cards, Nallatech has worked with HP and IBM to qualify FPGA hardware on a range of popular server and blade platforms. This allows customers to purchase integrated platforms directly from Nallatech or from HP or IBM under existing supplier agreements. All three procurement paths provide good value for money and reduce risk and time to market. By ordering line replaceable units as an integrated server or blade rather than just a card, customers can ramp up to production volumes quickly and rely upon a single warranty contract covering the FPGA accelerator card and the host platform. The Nallatech products are based upon the principle of an open architecture design. Customers like choice and typically hate black boxes, so the Nallatech FPGA cards can be used with the customer's preferred tool flow. For hardware-orientated customers who typically want to program in VHDL or Verilog, we market the FPGA cards under the network processing product family. Customers have upfront access to all the details of the hardware, and we provide the complete hardware pinout information. In order to make life simple, we test the cards using the Altera Mega Function IP from the Quartus tools, so customers can easily do the same when building their application. Over the course of the last 10 years, there have been many attempts to introduce high-level tools for FPGAs. Most have been offered by small companies with limited resources, using newly invented programming languages or even graphical user interfaces. Unsurprisingly, these attempts did not overcome the programming hurdle associated with FPGAs, particularly for software-oriented customers. The Altera OpenCL software development kit is a market-changing development that opens up FPGAs to a whole new audience and raft of application areas previously off limits. In our experience, software-oriented customers are often fearful of hardware and have no interest in the details of silicon or PCBs. Timing constraints don't mean anything to them, and clocks are for telling the time, aren't they? In Nallatech, we market the FPGA accelerator cards using language and terminology that software customers are comfortable with. We talk about kernels, libraries, and software development kits and actively hide the detail of the hardware. The Nallatech 385 is the lead hardware platform for the Altera OpenCL program, and we have plans to support the 395 in due course. Nallatech currently has 3 partners who add value to the Nallatech hardware and IP for the finance market. The first company is Interlop, based in the US. They provide customizable TCP IP offload engines, referred to as TOEs, plus Mac cores and optimized PCI Express DMA engines designed for high bandwidth and low latency. Interlop have a great reputation in the market and have successfully demoed a trading application featuring the Opera protocol on the Nallatech 385 card using a combination of IP cores and the OpenCL toolflow. For further information, please visit www.interlop.com. The second of Nallatech's partners is Velocitech, an award-winning company based in Denmark. Velocitech has a track record of successful FPGA and ASIC design wins and license agreements with customers in the finance market. They have just announced the introduction of a new Mac core that achieves an ultra-low latency of only 35 nanoseconds extremely attractive for finance customers wishing to minimize trading latencies. Nallatech is currently in the process of qualifying the Nallatech 385 card with their IP. For further information, please visit www.velocitech.com. Last but not least is Accelerate, based in Ireland. Accelerate is also an award-winning company, but rather than focusing on low latency applications for the finance market, they help improve the performance of software routines by executing them on hardware accelerators such as GPUs and FPGAs. The Accelerate product is cross-platform and has dramatically increased the performance of finance customers' applications such as Societe Generale. For further information, please visit www.accelerate.com. The next section of the presentation summarises a case study that Nallatech undertook during October 2012 using an early access version of the Altera OpenCL software development kit. A number of our customers highlighted the importance of data security and appear to be struggling as networks move to 10 gigabits per second and beyond. We thought that this would be a good problem to investigate and would represent a real-world test for the OpenCL toolflow running on FPGAs. If you think about it, networks are the arteries of the modern global economy. Governments, businesses, and individuals transfer sensitive information over public and private networks every day. People are now being encouraged to use and rely upon cloud services. Therefore, the ability to encrypt and protect data is more important than ever, with cyber attacks appearing in the news headlines almost every week. We decided to try and implement the popular AES encryption standard on the Nallatech 385 card. The AES algorithm consists of multiple bit shifts and exclusive OR operations, so the FPGA should be capable. We wanted to really try and push the limits a little, so instead of operating at 10 gigabits per second, we decided to try running at 40 gigabits per second. The Altera OpenCL software development kit made the task a lot simpler than if we were to program the application using a hardware description language such as VHDL or Verilog. We decided to partition the application so that the expansion key was running using sequential code on the x86 Intel processor of the host platform. The encryption core itself was the obvious part to try and accelerate using the FPGA, so we ran that section of the code through the Altera OpenCL compiler. The output was an SOF file, that is the file that executes on the FPGA as an optimized hardware implementation. The PCI Express Gen 3 bus was the connection for control and data path communications between the worlds of software and hardware. Despite the fact that we were using an early access version of the tools, our experience using the toolflow was actually very good, with the FPGA hardware working in concert with the software. We benchmarked the FPGA implementation against an Intel Xeon platform our engineers had easy access to, and a latest generation AMD Radeon graphics card. We were really pleased with the results we achieved. The FPGA managed a data throughput improvement of 130 times that of the microprocessor and 15 times that of the GPU. Where the FPGA really impressed was in the performance per watt. Energy efficiency and total cost of ownership are becoming major considerations for most customers. For this particular application, the FPGA was 520 times more power efficient than the microprocessor and 126 times that of the GPU. In order to try and visually illustrate the performance difference between the technologies, we attempted what is probably a first, a demonstration using PowerPoint. Basically, the takeaway message here is that the FPGA can process, in our case encrypt, significantly more data than the other technologies. The FPGA is therefore much more suited to dealing with real-time processing, even when programmed using a high-level toolflow such as OpenCL. We were keen to understand the performances achievable using the OpenCL toolflow, but just as importantly, we wanted to understand if the OpenCL toolflow could improve productivity, another gripe that customers tend to have when using FPGAs. We implemented the AES application using VHDL initially, It took one of our best engineers about 3 months. Using OpenCL, we managed to get it working from scratch in only 3 days. Not all projects will benefit from such a dramatic reduction effort. However, this first case study is very encouraging. The approach we took in this case was to test and optimize the code destined for the FPGA in the world of software first, using standard compilers for microprocessors and GPUs. This allowed us to compile and test iterations of a design in seconds and minutes instead of hours. Once we were happy with the code, we then ran it through the FPGA synthesis and place and route tools to generate the FPGA executable. That process took a couple of hours, but we only had to do it once. This example illustrates the power of OpenCL and demonstrates the freedom and choice it provides customers who are trying to choose their heterogeneous platform they need to maximize the performance of their application. There are a number of companies targeting the finance market with FPGA-based solutions. However, Nallatech stands head and shoulders above them all when customers require a quality hardware platform delivering the best price performance. Some of the key differentiators Nallatech have include the following. 20 years of successfully delivering FPGA hardware has resulted in Nallatech being acknowledged as the gold standard. The Nallatech 385 card is the main hardware platform for the Altera OpenCL program. In-house manufacturing, test and quality are dealt with by Nallatech's parent company, resulting in reliable products that can be purchased at competitive prices for both low and high volumes for the duration of the project's lifetime. Nallatech is the only company whose FPGA cards have been qualified by both HP and IBM, allowing customers to purchase integrated servers and blades. Nallatech has an engineering design centre capable of assisting customers partly or fully in the design and qualification of complex FPGA applications. Nallatech's value-add partner network allows customers to purchase pre-programmed FPGA hardware as appliances or IP and tools compatible with the Nallatech hardware. So, to summarise, Nallatech is one of Altera's leading hardware partners and a key part of the new OpenCL program. The latest range of Stratix V FPGA products are ideal for addressing the demanding requirements of customers in the finance market who are using FPGAs to implement applications dealing with low latency network processing or high performance co-processing. Customers can purchase Altera FPGA cards from Nallatech, HP or IBM as integrated servers or blades, dramatically simplifying the evaluation and deployment of FPGA products within heterogeneous platforms. Thanks for taking the time to listen to this webcast. For all the latest Nallatech products and information, please visit www.nallatech.com. You can download a copy of this presentation and webcast from www.nallatech.com/Altera-finance.